Good day, everyone. Today we are going to do on statics, force, and moment in 3D. So we are going to look at two questions. So my name is Dashalini. I'm going to teach you how to answer the questions. Okay, first question. So let's look at the question. Okay, the force F is equal to 700 newtons acts along line CD. Determine the moment of force F about axis OA. So line C to D and axis OA. So this is the answer. We can use as a reference at the end. Okay. So the very first step you need to know to answer this question is unit vector of axis. We need to solve the unit vector of axis. Lambda OA is the unit vector of axis. Very first, okay, first of all, you need to write the equation, which is MO. We need to find the moment of force about axis OA. So the moment is OA. So moment OA is equal to lambda OA dot product MO. Okay, so we're going to solve lambda OA first. So lambda OA is dx, dy, dz. Dx is 0.2, dy is 0, dz is 0.4. Okay, let's look at the diagram. Why I say like that? Okay, lambda OA. So this is lambda OA. dx is 0.2, dz is 0.4. Since the OA is in the z and x axis, so there's no y. See, the y is 0. Okay, so you plug in these values in the D formula and you'll get this. Using the coordinate method, you will solve lambda OA. Okay, so the next step is vector of moment of force along x-axis, which is the MO. Just now was lambda OA, now we are going to the MO. Okay. So MO, we can separate it into two, which is ROA times FCD. ROD. So ROD is vector from one point along the axis line to one point of the force line. FCD is vector from force F. So ROD, let's look at ROD first. Okay, so ROD. So ROD is 0.2. It lies on the x-axis. So ROD is 0.2 I. How about FCD? So I'll use another color for you to differentiate. Okay, so FCD is dx is 0.2, dy is negative 0.3, and dz is negative 0.6. Okay, so your dz is 0.6, dy is 0.3, and your dz is 0.2. Okay. See? Okay, since the force is moving to your right hand side of the x-axis and it's going towards the back and it's going towards down, so dx is positive, dy and dz would be negative. You plug in these values in the D formula and you using the coordinate method, you will find FCD, force for CD. And later, the third step is calculating using determinant. So this is the determinant. Okay, I've done it in an easier way. So you all can differentiate. Okay. So this is the answer for MO. Okay, so later, so you plug in the values for lambda OA and MO. And you have to use dot product. And the final answer is 53.4. Sorry, there will be a negative at the front. Yep, negative 53.4. So let's check. Yes. So if there's a slight difference in your answer, it's okay, never mind. And please make sure of the units. It's in cm. So make sure your answer also is in cm. Okay, don't forget that. Okay, now let's look at the second question. Okay, the second question is the force P is equal to 3640 newtons acts along line BD. This is BD. Okay, so determine the moment of force P about axis OA. So this is OA. So the answer is here. We can use it at the end. Okay. So first of all, same as the first question, we're going to, first step is unit vector of axis. Okay. So unit vector of axis is lambda OA. So we'll find what is lambda OA, dx, dy, dz. So let's look at OA. So OA is actually, it's on the z axis. So it is 1.2 dx. Sorry, dz, 1.2 dz since it's on the z axis. And dx, dy would be 0. And you plug in the value in the d formula and you will get lambda OA is equals to 1k. Next step is vector of moment of force along x-axis. Exactly the same as question 1. You have to write the formula for MO, ROD times FBD. Okay, so ROD. Okay, so I need to tell you all that this ROD times FBD, how are we extracting this formula? Okay, so this ROD is actually any line which connects to the force. We can also take ROB because it's connecting to the force BD. Or we can take OD as well since it's connecting to the force BD. So it can be ROD or ROB as well. So please make sure that you guys, please remember that we don't simply take it, we need to look at the force. If OD connects to the force, then we can use R for that. OB connects to the force, we can use that as well. Like OA, it's not connecting to the force BD, so we can't take that. Okay, so ROD times FBD. So ROD is your y-axis, which is 0.8j, and FBD, dx, dy, dz. Okay, let's look at this. FBD, so BD. So your dx, okay, so dz is 1.2. X is 0.9. And your y is actually 1.1 because 0.8 plus with 0.3 because your force is from B to D. Okay, so please make sure of the negative positive. Okay, so since your arrow, your force is going towards the up, towards Y, and it's going towards the left. So yeah, it's going towards the left. So your X would be negative and it's going to the back. So dx is also, dz is also negative, only dy is positive. And you plug in the values in your D formula, and then using the coordinate method, you find what is force BD. And the last step, calculating using determinant. Use the determinant method to find MO. And at the end, you're using the cross product. Sorry, dot product. You're using the dot product. This is the dot product. Determinant is the cross product. This is cross product. This is dot product because there's a dot here. Okay. So at the end, you get the answer. This is the answer. So let's check. Okay, so we have a slight difference in the answer. So this is the answer. Please make sure of the unit, guys. See here, it's given as cm. Please don't mind the answer. The answer here is wrong. So your final answer, make sure it's in cm. If not, you might get the wrong answer. Okay, guys. Thank you very much for joining me today. I hope you guys do more activities to improve yourself in these kind of questions. Thank you.